Our goal in engineering services is to help our customers be successful, whether in design, analysis, prototyping, or manufacturing. They have deadlines and need solutions to their problems, so they come to Breault to get the optical engineering expertise they need. We start with their requirements and develop a proposal to meet those requirements within their budget and schedule. One such customer we supported is Cinedon in the development of their realSens radiometer.
Cinedon's a wonderful example of the type of project that Breault's done for a customer that's really a comprehensive service. And for example, they came to us several years ago and they had a conceptual design for an instrument at that time, and they said, "Breault, we'd like you to take a look and review this instrument, critique it, and tell us what you think." Today, Cinedon is flying that same instrument that Breault designed and fabricated on a helicopter to detect methane gas leaks for a wide variety of different applications. To describe to you a bit further the type of service that Breault provides to its customers, and also to explore this realSens instrument that Cinedon has asked us to help to develop, let's start from the beginning and go back to the conceptual design that Cinedon provided us to evaluate. Cinedon has developed a remote sensing instrument to measure natural gas leaks, and they've referred to that system as the realSens system. And the realSens system flies on a helicopter at 300 meters altitude and travels at about 100 kilometers per hour and captures a swath of ground that's about 64 meters wide. And from the data that's captured through that flight, Cinedon can generate a map of natural gas leaks with a ground resolution of about 2 meters. In the conceptual design review, we reviewed the optical system performance, that is its image quality. We reviewed its radiometric performance, starting with the sun, that light bouncing off the Earth's surface, and then propagating through the instrument to the detectors. And we took a very close look at how stray light might impact instrument performance. Throughout the design phase of the Cinedon project, we used Breault's Advanced Systems and Analysis program extensively. In fact, one of Breault's engineers used ASAP for a large number of system analyses on the realSens radiometer. For example, we used ASAP to simulate image quality. We used ASAP to simulate stray light within the sensor. And perhaps most importantly, we used ASAP as a virtual prototyping tool, and we simulated manufacturing errors, assembly errors, all inside of ASAP's package. ASAP was an essential tool to meeting the objectives that we established for the preliminary and the detailed design phase. During the detailed design phase, we began by designing a test station that would be used here at Breault Research to verify the performance of the imaging assembly and the radiometer. We developed comprehensive specifications for each component, and we did detailed drawings for each and every element within the system. At the completion of the detailed design phase, we upgraded the system model that was a SolidWorks CAD model. And let's take a couple minutes and go tour that CAD model and look inside.
Yeah, the Cinedon project required a tremendous amount of mechanical engineering and structural engineering as well, following the optical design. So once the optical design was done, that's where the structural and the mechanical take over. On Cinedon, we provided the opto-mechanical engineering services as normal, and that went starting at conceptual design through the different optical design phases, and we were there to support the optical design in that we needed the optics to fit into whatever mechanical package was going to be. So you start on the optical end, and you have to handhold with the mechanics and what you think that's going to be and how much you think that's going to weigh, and can you mount the optics, and can you center the optics, can you get the system aligned, that sort of thing. So every step of the way we were there to help things go through without problems.
And after we completed that upgrade of that CAD package, we assembled a documentation package that included all of the drawings and all the pertinent specifications for the hardware build. And we presented that material to Synodon. And with Synodon's approval, we proceeded to the prototype phase of the job, the hardware phase of the job, to go ahead and fabricate a radiometer and a realSens enclosure. Now in the final phase of the program, the hardware phase, we subcontracted the manufacture of each and every component to approximately 30 different vendors. We then received all of those components and performed all of the assembly, integration, and test at Breault's facility. After Synodon signed off on the radiometer performance, we went ahead and integrated the radiometer into the realSens enclosure. We added the mounting hardware that Synodon would use to install the remaining instruments to make up the realSens system, and we delivered that unit in place to Synodon. Synodon then took the realSens system to the Tucson International Airport for flight certification testing, and after completing that testing, they flew over a series of measured natural gas leaks to demonstrate the performance of the system in flight for the very first time.
All right, we've got the helicopter flying down the length of the road. We put an ethane leak about 30 meters down the road, just off the road. And,
today, I am very pleased to announce that Synodon is flying over a number of different natural gas leaks for a wide variety of applications and a number of customers. So we very much enjoyed working on this project. And through this case study, I hope you can see the various services that Breault's Engineering Service Group provides, and we would welcome the opportunity to work on your project, whether big or small.